All right, welcome to another edition of Geometry. This is the 2.5 concept guide, which is on perpendicular lines. This time, I'm sorry, y'all. I've got a bad cold. I've been blowing my nose like crazy, and my nose is all red. It's kind of embarrassing. Just call me Rudolph. Hope that doesn't bother you here. Anyway, let's get going. All right, two lines are perpendicular if they intersect to form right angles. Okay, that is like the definition of perpendicular. If they intersect to form right angles. The symbol that we will use for perpendicular is this, just a horizontal and vertical line like this, kind of an upside down capital T. That means perpendicular. You've talked about perpendicular before in algebra with respect to slope. Do you remember that the slopes of lines that are perpendicular are opposite reciprocals? So like if the slope of one line is -3/4, then they're 4/3 for the other. That still applies, but that's not going to be our focus here in this section of material for sure. So based on this idea of perpendicular forming right angles, there end up being some, things that we can then know. Rule number one, if line K is perpendicular to L, then measure angle 1 equals 90 degrees. That's the definition of that perpendicular. And, because angle 1 and angle 2 form a straight angle, then it's also equal to 90 degrees because they add up to 180. Well, then angle 1 and angle 3, those are verticals, so it's also equal to 90 degrees. And then angle 4 is also equal to 90 degrees. So when you have two perpendicular lines, if they intersect each other completely, then you end up with 4 right angles. So in other words, if two lines are perpendicular, then they form right angles. And if two lines form right angles, then they are perpendicular. It goes both ways. That is a biconditional. So we could say two lines form right angles if and only if they are perpendicular. So that's rule number one. All of that together is really, I call the definition of perpendicular. If it's talking about perpendicular lines and right angles, 90-degree angles, all that goes together. The definition of a right angle is one that equals 90 degrees. All right, that leads to perpendicular rule number 2. If two lines are perpendicular, then they form congruent adjacent angles. Wait till we get to the diagram here in a second, but we can flip that around. If two lines form congruent adjacent angles, then they are perpendicular. That's what type of conditional? Biconditional. It goes, the conditional statement and its converse are both true. Here's what this is saying. If you have perpendicular lines, there are two congruent angles, ADB and BDC. Well, they are adjacent, okay, and they are congruent because they're both equal to 90. So if you have perpendicular lines, then you have congruent adjacent angles. That's just taking what we were saying about in step 1, just a step further. It's adding a condition, adding an element to those things that they're equal 90. You don't have to say they're equal 90 and say that they're congruent. We can just go ahead and say that they are congruent. Okay, rule number 3. If, with the angle addition postulate, two adjacent acute angles form perpendicular sides, then the two angles are complementary. It's easier if we look at this in the form of a diagram. Here in this example, segment AB is perpendicular to AC. That means we got a right angle over there. We have two acute adjacent angles. Then those two angles are complementary because they add up to 90. They form a right angle, in other words. So if the two sides, after you add two angles together, are perpendicular, then you have two complementary angles. And it makes more sense by the diagram, I think, than the words. You can agree or not. Okay, so the first set of questions that we end up having to answer here is just to name the definition or state the theorem that justifies the statement. Give the reason that makes this true. So in question A here, if these two lines are perpendicular, then the 4 angles are right angles. Which of the rules above does that apply to? That was rule number 1, or the definition of perpendicular. Question B here, if angle 1 is congruent to angle 4, then they are perpendicular. Well, that was saying if these are congruent, then you have a perpendicular lines. That was what rule number 2 was stating. How can we say that that's true? If they're perpendicular, then they're congruent. I'm sorry, if they're congruent, then they are perpendicular. That's rule number 2. If the measure of angle 1 is equal to 90 degrees, then these two lines are perpendicular. Which one of those was that talking about above? If it forms a right angle, that was rule number 1, the definition, perpendicular. What about angle 1 is congruent to angle 3? What makes that true? Does that have anything to do with those lines being perpendicular? No. That's because vertical angles are congruent. What about angle 1 plus angle 2 equals 180? Does that have anything to do with them equaling 90 degrees or anything to do with perpendicular? Not really. That is the angle addition postulate. Angle 1 plus angle 2 form a straight angle. It doesn't matter whether they're both 90. They are, but that's not what makes them equal 180. It's because it's the angle addition postulate. All right, give these a try down here at the bottom and see what you think. I have a feeling a few questions will generate from this, but pause the video. I'll come back to you in a few seconds. So number 4 really has nothing to do with perpendicular lines at all. If angles 7 and 8 are complementary, then they add up to 90. That's the definition of complementary. Number 7 here is the definition of a right angle. That has nothing to do with perpendicular lines. That's the definition of a right angle. All right. What I'd like for you to do here is follow along with me on this example of this really gets to be one of the more important types of questions you'll be answering with this kind of stuff. If these two lines are, or these two rays in this case, are perpendicular, we have a right angle, WZY. Angle WZY is a right angle. Go ahead and mark your diagram. And what does that mean? Well, angles 1 and angles 2, angle addition postulate, add up to that 90-degree angle, so they are complements. That was rule number 3. Therefore, measure angle 1 plus measure angle 2 equals 90 degrees. We can substitute measure angle 1 as 5x, measure angle 2 is 2x minus 1. We have our equation, and we can solve it for x. X equals 13. Be prepared to answer this question. What would the measure angle 1 equal? 65 in this case. 5 times 13 is 65. What's the measure angle 2 equal? In this case, it's 35. 65 plus 35 is 100. Wait. 65 plus 25 is 90. Oh, seeing if you're paying attention. Hey, speaking of seeing if you're paying attention, if you'll write the word left angle on the bottom right-hand corner of your page, as opposed to a right angle, that will help me know if you're paying attention. So try these questions 8, 9, 10, 11, 12 on your own. Let me help you get this set up here. If line ray BE is perpendicular to line AC, then we have right angles here. Then if ray BD and BF are perpendicular, then we have a right angle here. So we're going to have complementary angles kind of throughout here. If they're complementary, of course, they're going to add up to 90. See if you can make some equations and solve for x here, 8, 9, 10, 11, 12. These are the answers. It's worth noting on number 10, there were a bunch of different ways you could have done that. You could have said angle 1 plus angle 2 equals 90. You could have said angle 2 plus angle 3 equals 90. Angle 3 plus angle 4 equals 90. Or you could have added all 4 of those together and they would equal 180. So you should get the same answer no matter what. Okay, here's the fill-in-the-blank proof. I'd like for you to try on your own, and then I'll walk through with you here in just a second. So pause the video, see if you can fill in whatever you can without my help first. Okay, so first, that's given. Mark your diagram if you didn't. So if BA is perpendicular to AC, there is that. So then how do we know that angles 1 and angles 2 are complementary? That was perpendicular rule number 3. Those two angles are complementary because their sides are perpendicular. okay, or the sides of them added together. How do I know that angles 1 and angle 3 are complementary? That was given. Okay, so then how can we say that angles 1 plus angle 2 equals 90 and 1 plus 3 equals 90? Definition of a complement. The definition of complementary, or of complements, yeah. That's what that means to be complementary. So then, angle 1 plus angle 2 equals 1 plus 3, that's substitution. What got substituted? Both of these are equal to 90, therefore they're equal to each other. This measure angle 1 plus angle 3 took the place of that 90 right there, because it's also equal to 90. What's going to have to go into this reflexive property and so that we can end up with measure angle 2 equals measure angle 3. The spacing down there helps you out a little bit. But measure angle 1 equals measure angle 1, which allows us to subtract measure angle 1 from both sides. Hopefully we'll be getting better and better at that. All right. Gosh, I'm tired. I'm sure you are too. Let's get some rest.